Hey guys, I'm gonna go through these FRQs. Let's see if I can speed run them while still making sense. So for the first FRQ, we have a graph of the function f in the xy plane. The graph of f has a vertical asymptote at x equals -2. The function g is continuous and increasing for all x. Values of g at select values of x are shown in the table. So we got f and we have g. Use the graph of f and the table for g. Estimate the limit as x approaches 1 of this expression. So we're just going to use some properties of limits. Yep, that's the word. To evaluate this. So this will be equal to 2 times by the limit as x approaches 1 of f of x. So I'll go over here. We got x here. So the limit as x approaches 1 seems to be 4. And so that's going to be times by 4 plus 3. And then the limit as x approaches 1 of g of x. So looking at the table for g, we have x values. They're approaching 1 right here. So 1 would be somewhere in between here. And the y values seem to be approaching 5 from either side. And so that's going to be times by 5. And then simply that's just going to be 8 plus 15. And that's going to be equal to 23. So there you go. For the next part right here. So 16, 17, 18, 19, these are all with having to do with this information here. So for each of the values, a equals -2, a equals 2, and a equals 3, determine whether or not f is continuous at x equals a. In each case, use the definition of continuity to justify your answer. So the definition of continuity is that the limit as x approaches a of f of x has to equal f of a. So what they're saying, in each case, use the definition to justify. So if it is continuous, you'll show that this is true. And if it's not continuous at one of these values, then you have to show that it's not true. Or that it's not equal to each other. So let's start with just a equals -2. So then that would be showing what the limit as x approaches -2 of f of x is. So limit as x approaches -2. Now you can see that the from the left side it's from either side it's unbounded. So I can tell you that the limit as x approaches -2 of f of x does not exist. You can also state that f of -2 is undefined. And so that is also justification enough right there to state that f is not continuous. So f is not continuous at x equals -2. That should be good right there. Now for a is equal to 2, so let's evaluate the limit as x approaches 2 of f of x. So limit as x approaches 2, you can see from the left side it's 4, from the right side it's 4. So that's going to be equal to 4. And I guess you could say this right here, and that's equal to f of 2. F of 2 is also equal to 4. And so you can say that f is continuous at x equals 2. Alright, and then for a is equal to 3, the limit as x approaches 3 of f of x is going to be equal to, let's take a look here. So limit as x approaches 3, right here, it looks like it's from the left side it's 0, from the right side it's also 0, so it's equal to 0. But f of 3 does not exist. So f of 3 does not exist, or I'll say is undefined. Right? So f is not continuous at x equals 3. So yeah, I think that should be good right there. All right, for this next part right here, find the value of the limit as x approaches 0 of f of x. So this is a composition, or explain why the limit does not exist. So let's evaluate the limit as x approaches 0 of f of x. So this is the inside part f of x, not the outside part. So the limit as x approaches 0 of f of x. Let's go up here, limit as x approaches 0. Now I'm going to have to do two limits because from the left side it's something different from the right side, and so I'm going to have to do two different limits. So we'll do the limit as x approaches 0 from the left of f of x, and we'll do the limit as x approaches 0 from the right of f of x. So from the left side, it's equal to 1. And we also need to state that it's coming from above, not from below. So it's going to be equal to 1, but from above. Now, as we evaluate 0 from the right, it's equal to 2 coming from above. So I'm going to say 2 from above. Now, we're going to evaluate the limit as x approaches these values right here. So 1 from the right of the outside function. So now we're evaluating the outside function. So the limit as x approaches 2 from the right of the outside function. So the limit as x approaches 1, from the right side is equal to 4. And the limit as x approaches 2 from the right is also equal to 4. And since these are equivalent, we've identified that the limit as x approaches 0 of f of x is also going to be equal to 4. So yeah, there you go. Write a difference quotient that best approximates the instantaneous rate of change of g at x equals 1. A difference quotient is y2 minus y1 over x2 minus x1. That's a difference quotient. So slope is a difference quotient. So, and then that's how you approximate instantaneous rate of change, is by using the slope of a secant line. So at x equals 1, we're also talking about g, not f. So we're trying to approximate the slope at x equals 1. So I'm going to take the smallest interval of x possible around x equals 1. So I'll use these values right here. So I can assign this to be, I'll assign this to be y2 right here, this to be y1, this to be x2, this to be x1. If you want, you can also use function notation. So you can say g of 1.001 in place of 5.004. Doesn't really matter. I'll do it both ways. So we can say g of 1.001 minus g of, so again, we're looking for 1 to be in the interval, which it is, in between here, and we're using the tightest interval here. So I'm going to use 0.999 all over 1.001 minus 0.999. If you want, you can also write it as 5.004. That was the y value right here, right? Yep. And then 4.996 minus 4.996 over 1.001 minus 0.999. So either of these will be acceptable. But yeah, just make sure that you have a difference quotient. One of those two. Make sure it's not flipped. Make sure you're not doing the x values on the numerator. These can be flipped as long as it's consistent with these values right here. That shouldn't matter. That won't matter. Again, these can be flipped as long as these are also kind of flipped as well. But what can't be flipped is the numerator and denominator. Okay. All right, and that's question 1.